Problem Introduction. Hey everyone, and welcome back to the channel. Today we're tackling LeetCode problem number 38, Count and Say. This is a medium-level problem often used in coding interviews, and it's a great example of how dynamic programming can simplify a seemingly complex task. The problem statement is deceptively simple. Given an integer n, generate the nth string in the count and say sequence. The sequence starts with 1. To generate the next string, we read the previous string and describe it. So, 1 is read as 1, 1, resulting in 1, 1. Then 1, 1 is read as 2 1s, giving us 2, 1. 2, 1 becomes 1, 2, 1, 1 because it's 1, 2, 1, 1, and so on. The challenge is to build a function that efficiently generates the nth string in this sequence. We'll explore different approaches, analyze their complexities, and finally arrive at an optimal solution. Get ready, let's dive in. Understanding with examples. Let's solidify our understanding with a few examples. For n equal 1, the result is simply 1. For n equal 2, we read 1 as 1, 1, so the result is 1, 1. For n equal 3, we read 1, 1 as 2 1s, giving us 21. Now for n equal 4, we analyze 21. We have 1, 2, 1, 1, resulting in 1, 2, 1, 1. And for n equal 5, we describe 1, 2, 1, 1 as 1, 1, 1, 2, 2 1s, which gives us 1, 1, 1, 2, 2, 1. See the pattern? Each string is a description of the previous one. This pattern is the core of the problem. Understanding this recursive nature is key to developing an efficient solution. It's a bit like a verbal puzzle, but we can turn this verbal description into code efficiently, and that's what we'll be doing in the following scenes. Brute force approach. A brute force approach would involve iteratively generating each string in the sequence until we reach the nth string. We'd start with 1, then generate the next string based on its description, and repeat this process n times. However, this approach has a significant drawback: its time complexity. Because we're generating each string from scratch, it's not efficient at all, leading to exponential time complexity. This means the time taken grows rapidly as n increases, which isn't ideal for larger inputs. It's a simple approach, but definitely not efficient. Let's see how we can improve this with a better algorithm. Optimal solution. The optimal solution leverages dynamic programming. Instead of recalculating each string from scratch, we store and reuse previously computed results. We can build the sequence iteratively. We'll start with the base case, 1, and then build up to the nth string. For each iteration, we'll scan the previous string, counting consecutive occurrences of the same digit. This count and the digit itself will form the next string in the sequence. This iterative approach significantly improves the efficiency of our solution. By building upon previous results, we avoid redundant calculations and reduce the overall complexity. Code implementation. Let's see the code in Python. We'll use a loop to iterate from 1 to n. We'll start with the base case, 1, then in each iteration, we'll process the current string to build the next one. We'll use a helper function to count consecutive digits, and then we'll build the next string accordingly. This iterative dynamic programming approach ensures that we're not repeating calculations unnecessarily. The code is clean, efficient, and directly reflects the logic we've discussed. This approach is much more efficient than the brute force solution we saw earlier, and this makes all the difference, especially when the value of n is large. Time and space complexity. Now let's analyze the time and space complexity. The time complexity of our optimal solution is O of n. This is a significant improvement over the exponential complexity of the brute force approach. We iterate through the string only once in each step, and the length of the string grows linearly with n. The space complexity is also O of n because we store the intermediate strings. It might seem that we are storing the previous results, so it could lead to a lot of memory use. However, this space is proportional to the length of the final string, which is linearly related to n. So we have a linear time and space complexity, a vast improvement compared to the brute force solution. Engagement break. Before we conclude, I want to ask you to show your support. If you found this explanation helpful, please give this video a like and subscribe to the channel for more LeetCode tutorials. Don't forget to leave a comment below if you have any questions or suggestions for future videos. Your feedback is incredibly valuable, and it helps me create even better content for you all. Let's keep learning and growing together. Conclusion. So there you have it, a comprehensive walkthrough of the count and say problem. We started with the problem statement, explored different approaches, analyzed their complexities, and finally implemented an efficient solution using dynamic programming. Remember, understanding the problem, identifying the optimal approach, and analyzing the time and space complexity are all crucial skills in coding interviews. Mastering these skills will significantly improve your problem-solving abilities. I hope this tutorial was helpful. Don't forget to like, subscribe, and share this video with your friends if you found it useful.